Hi, I'm Hadley Pinder, and I'll be doing problem number 1. So it says, this question concerns the molecules involved in translation. Part A, indicate the group of enzymes that covalently link amino acids to the tRNA molecules. So this is the amino acyl tRNA synthetases. And part B says, indicate 4 proteins that consume GTP during translation. So that would be the EFTU, the EFG, the IF2, and the IF3. They all require energy. And for part C, indicate 1 molecule that functions as a ribozyme, and that is the peptidyltransferase, or the T3S rRNA. Indicate 2 proteins that recognize the stop codons, and that would be the release factor 1 and the release factor 2. And then indicate 1 molecule that forms hydrogen bonds with the Shine-Delgarno sequence in the mRNA. And that would be the 16 rRNA that's a part of the 30S subunit. So.
All right, I'm Tyler, gonna do number 2. So it's the vocab question. Fill in the blanks. Now, part A, the first amino acid in prokaryotic proteins is formylmethionine in prokaryotes. An E. coli protein called blank delivers charged tRNAs to an A site of the ribosome during translation elongation. It's the EFTU. Part C, the initiator tRNA binds to the P site of the ribosome, whereas the remaining charged tRNAs bind to the A site of the ribosome. Part D, blank, which is the EFG, is a translation factor that helps the ribosome move 1 codon in the 3' direction along the mRNA strand. And then part E is IF3 is a translation factor that guides the mRNA to the 30S ribosome subunit. And then F is AUG is the start codon, while there's 3 different ones, but UAA is an example of a stop codon. And then G is degenerate is a term that indicates that more than 1 codon can specify the same amino acid. H, the final amino acid, is located at the N-terminus of the polypeptide.
Okay, hey, I'm Donovan Wixom, and I'm doing question 3. It says, a series of mRNA codons are indicated. Consider the Wobble rule and provide all possible tRNA anticodon sequences that can form hydrogen bonds with each mRNA codon. So A through E are all listed as 5' to 3'. So we know right off the bat, all the tRNAs are going to be 3' to 5'. So instead of writing that for every single one of them, I just wrote it once. And then following, well, let's just, A says 5' UUG 3'. So following the Wobble rule that is outlined in the table in our notes, for A we get AAC, AAA, and AAU. B, the anticodons for AGU, the anticodons for AGU are UCG, UCA, UCU, and UCI. The anticodons for UAC are AUG, AUA, and AUI. The anticodons for AUU are UAG, UAA, UAU, UAI, and finally for E, the anticodon for GCA is either CGU or CGI. That's it.
Okay, so I have question number 4. My name is Bradley Wilkerson, and for number 4, it gives us the kilodaltons in our protein? Yes. And then it also gives us the average Dalton per amino acid. I just indicate amino acid by A. And so kilodalton is just 1,000. So we have 218,000 Daltons. Sorry, my handwriting. And then to get how many amino acids we have to divide this number by our average amino acid count, which is 125 Daltons per amino acid. And so we divide that by 125. When we do that, we get 1,744 amino acids. Okay. Now, once we have this one, this is the answer for part A. Now, for part B, we're trying to figure out how many GTP we get, well, that needs to be used to form this protein. And so for GTP, when we have our initial, we actually add one amino acid. So I just added, I kept it in here instead of writing it separate. So it's just 2 times the 1,744 because that includes the MET amino acid onto it. And then you add 1 because it takes 1 GTP to separate the ribosome and to make your acid complete. And so when we do this, we get 3,488 plus 1, and we get 3,489. And then you don't do the plus 1 because that's what the answer is. So we have 3,489 GTPs that are used to make our protein, not protein.
Yes.
Yeah, protein. And then we want to figure out how much ATP is needed to make the same protein. Now ATP, there's only one ATP that's used per amino acid because each tRNA is linked up to amino acid, and to charge those tRNAs with that amino acid, it just takes 1 ATPs. And so if it's just 1, it's 1 times how many amino acids we have, and we have 1,744. So the answer to C would just be the 1,744. Oh, I went of. Wait, this is actually answer to D, and this is the answer to C.
Oh.
For B, the one I skipped, we're trying to find the length of the mRNA, so how many base pairs it has. For base pairs, we have to take how many amino acids we have. Each amino acid is linked up to 3 bases. So we'd have to have 3 times the amino acid count. And so when we do that, we get, let's see here, 5,300. No, 5,232 base pairs. Yeah, that's 5.
And E.
Oh, and E. E is just down here. I have it's the amino acetate tRNA synthesase. Right there.
Yep. Okay, it's me again. I'm back. Close. Oh. Question number 5. Hold on, let me get it here in front of me. Okay, so question number 5. There's a list of vocab stuff. And so for part A, it says, which of the above is involved in translation initiation? We got 16S rRNA, the Shin del Garno, I think is how it's said, IF3, 5' AUG 3', tRNA FMET, and IF2. Part B wants to know which of the above are involved in elongation. We got EFTU, the lysyl-tRNA synthetase, that's really hard to say, EF-G, 23S rRNA, and 16S rRNA, again, because it has does some proofreading during elongation. For C, which of the above is involved in termination? We got RF1 and 5' UGA 3'. For part D, what is the above are components of the 70S ribosome? The 16S rRNA and the 23S rRNA are components of the ribosome. And for part E, which of the above are found within the mRNA, the Shin del Garno, the UGA, and the AGU? And that's it. Bye.